Welcome to the UGC lecture series. In this lecture, we are going to talk about recovery. This is also associated with ensuring asset properties, which in the last class we spoke about concurrency. Here we are going to talk about recovery. So, in this lecture, we are going to talk about the different types of failures, and then we are going to outline what is meant by log based recovery. We are going to explain what is meant by shadow paging, and then we are going to discuss the various types of media failures, and then we are going to outline the two phase commit protocol. One of the many very important criteria for a database is the requirement for database consistency. All others can be tolerated, but inconsistency in a database cannot be tolerated. So, system failures either hardware or software must not result in an inconsistent database. This is one of the fundamental requirements of a database, otherwise no one will use a database. So, which essentially means a transaction must execute in its entirety, or it should not execute at all. Okay, that is the meaning of consistency. So, what are the types of failures that can occur? One is system crash, can be due to hardware or software errors, and can be result in main memory loss. Application software errors, logic errors in the programming accessing the database, which can cause some transactions to fail, or natural physical disasters such as flood, fire, earthquake or power failures. So, sometimes failures can be caused by carelessness or unintentional destruction of data without saving, media failures such as head crash or unreadable data, or sometimes purposely done by sabotage or intentional corruption of either data, hardware or software. So, basically we can divide failures into four: system failures, media crashes, communication failures and transaction failures. When we talk about recovery facilities, a database management system should provide the following to assist in recovery. One is it should provide a backup mechanism. What is the meaning of a backup mechanism? Periodically a copy of the database should be made and kept. So, that is what is called as backup. Then you have to have logging facilities. What is the meaning of logging facilities? It means that you have to keep track of what is the current state of the transactions and what is the current and what are the changes that has been done to the database because of these transactions. So, what is the current state and what are the changes? Then you have to have what is called a checkpoint facility, which enables updates to the database that are in progress to be made permanent. That means, I have done a write, then the write has to be made permanent. The meaning of this is it should be stored in a permanent memory. So, when that has to be done, when that update has to be made permanent, and then you have to have what is called a recovery manager, that is it allows the system to go back to a consistent state after a failure has occurred. So, you cannot prevent failures, but when a failure has occurred, you must have enough information so that the database goes back to a previous consistent state. So, this is why you need all the other three. You need a backup mechanism, you need logging facilities to keep track of what is the state, so that when a failure occurs you can go back or roll back, and you have to have a facility where at certain points of time you are making or you are storing the database and into a permanent, so that even if failure occurs nothing will happen. So, we go to different types of recovery. One type of recovery is what is called as log based recovery. So, this is sometimes called as after image or redo log. The system maintains a log in order to enable recovery from transaction failures. So, it keeps track of all the transaction operations which affect the values of database items, which automatically means that read is not a problem, it is the write operations that have to be really kept in log. So, that but suppose the read has read something which is not yet correct, or it has some transaction has written X, the data item X, and it has not committed, but transaction 2 has read this. Now, transaction 1 rolls back, then the new write value is lost, but transaction 2 will be having that value. So, read also comes into the picture. So, you need to keep track of both the read operation and the write operations associated with all transactions. So, the log is normally kept on disk, so that it is not affected by failure except for catastrophic failures. The only protection against those type of failures, that is where physical failures occur, is to have a backup, and the backup to be stored in some other place obviously. So, what is the meaning of a checkpoint in a system log? Now, checkpoint, the point of synchronization between the database and the transaction log. All buffers are force written to the secondary storage. So, at a checkpoint state, it means that if the database is not reflecting all the changes in the transaction log, then at this point, at the checkpoint, all the buffers which are there, which the transaction has written or read from, are all forcefully written onto the secondary storage. That is the checkpoint. So, at the checkpoint, the database and the transaction log file are consistent. A checkpoint record is written periodically into the log when the system writes out the database on disk, and it will affect all write operations of all committed transactions. Now, all transaction whose commit transaction ID can be found in the system log will not require the write operation to be redone in the case of a system crash, because all the write operations have already been committed, that means written on to the disk, and even though they can be found in the system log, before the checkpoint whatever happened you do not have to do anything, because already those write operations have been already committed and stored. So, you do not have to redo it, and it limits the amount of searching and processing that you have to do on the log file. If you did not have checkpoints, what will happen? Throughout whatever has been done has to be looked up and all that has to be processed. Now, if you have checkpoints, only up to the checkpoint point, up to the, at the checkpoint point you know that consistency is there, after that only there is a problem. So, that you know. So, what is the actions that constitute a checkpoint? Taking a checkpoint consists of the following actions. Temporary suspension. So, when you are doing a checkpoint you cannot do execution of a transaction. So, there will be a temporary suspension, and then whatever database blocks are there in the main memory buffers due to write operations, they all have to be forcefully written onto the disk. Then you write a checkpoint, that is checkpoint has occurred, that has to be recorded on the log, and force writing that log also has to be written to the disk, and then you resume the transaction execution. Okay. So, that is the so again temporary suspension, forceful writing from main to disk, forceful recording the checkpoint, and then writing that log also, because log also can be lost. No? So, the log also is written to the disk, then you resume. So, what are the recovery techniques? There are a number of recovery techniques. One is called deferred update technique and the other is called immediate update techniques. Now, deferred update techniques, database is not modified until after the transaction reaches its commit point. So, database is not modified until after the transaction reaches its commit point. Until the commit point comes, nothing is modified. So, though you have written long back and then you have not reached the commit point, you do not write that. So, that is called deferred update, you do not update. Immediate update, what happens? Database is updated as and when the transaction progresses. However, the updates are logged before they are made in the database. So, you know what are the things that have been updated. So, what is the deferred update protocol? A transaction cannot change the database until it reaches its commit point. A transaction does not reach its commit point until all its update operations are recorded in the log and the log has been force written to the disk. So, overall strategy is following. So, this is ready to commit state. When it is only in the ready to commit state, it can be written, and it does not reach its commit point until all this we have already seen, and the log is force written. So, the buffer cache holding logs are flushed. What is the meaning of recovery using deferred updates? No undo of any transaction is required, since transactions do not affect the database until committed. Since all logs are released only after commit, no transaction can read a data element that is being modified by another transaction. Therefore, no possibility of cascading rollbacks, but however, heavy disk operations during the commit, because you are doing everything together. So, at that point when you are doing commit, there will be heavy disk operations. This is one disadvantage that you have for deferred updates. So, again what do we do in deferred updates? We do deferred updates means we do all the updations only at the commit point. Okay. So, until all the database transactions, since transactions do not affect the database until it is committed, till then it is a temporary business. So, only when the commit occurs it becomes permanent, and only after all the operations are done, after the commit operation, logs are released. So, since the log is still available with this transaction, no other transaction can reach this data item, and therefore, there is no possibility of cascading rollbacks. The only problem is at the commit point there is heavy disk operations. The other protocol is the immediate update protocol. This is the write ahead log protocol. A transaction cannot update the physical database until all undo type log records for that transaction up to that point in time have been force written to the disk. That is, transaction is not allowed to complete the processing of commit until all redo type and undo type of log records. That is, we remember in 2 or 3 lectures back we had spoken about what are the types of transactions: redo, undo, commit, all those. So, redo and undo will also be written in the log record. So, all that has to be written on the disk, and until then you are not allowed to do any update. In a single user environment, use two lists of transactions, list all committed transactions since the last checkpoint and list all active transactions till the last checkpoint. Undo the writes of all active transactions using the undo policy, redo the write operations of all the committed transactions, submit all active transactions again to the database. So, this is the process of recovery. So, what do? You have two lists of transactions, one is called as committed transactions and the other is called as active transactions. So, what you do for all active transaction undo, for all committed transaction redo. We are talking about writes only. So, and then the active transactions are committed back to the database management system. Next is, when we are talking about lot of this memory, main memory and disk, we have to talk about cache management also. So, underlying operating system uses buffer caches in conjunction with read ahead and delayed writes for improved performance. So, updated data in the buffer cache that are not written to disk are lost when there is a crash. Remember, we are talking about recovery management. So, typically a part of the buffer cache called database cache, management cache, is kept under the control of the database management system other than the operating system. Crash recovery for cache pages are handled using something called shadow paging, which we will talk about later. So, what we are trying to tell here is some buffer cache must be at the access of the database management system and not the operating system, because otherwise what will happen is this buffer cache, if it is not written to the disk, will be lost during crashes, and the whole purpose of the whole thing and the cache and the storage and all is to do recovery management. So, let us talk about why the crash recovery for the cache pages is handled using something called shadow paging. So, what is the shadow paging? This requires no write ahead logging, updated data kept in a different location from the original data. So, recovery entails discarding the new page and reverting to the original shadow page. Normally you say shadowing. So, what you have is you have a original page and you have a different location, the original data and what you are operating on. So, when this crashes or something happens, then you can go back to the original. Of course, this has a problem of fragmentation over extended operations. The scheme uses a number of fixed size disk pages. This is similar to our operating system page management. So, scheme uses a number of fixed size disk pages, say n, for recovery purposes. So, a page table with n entries is constructed where the ith page table entries points to the ith database page on the disk. So, this way you have pages associated, and when a transaction begins executing, the current page table is copied into the shadow page table, which is then saved, and during transaction execution it is never modified. So, the original page stays as it is. You take the shadow page stays as it is, the original page is the one that is modified. So, if a crash occurs, you go back to the shadow page. So, during transaction this shadow page table is never modified. So, when you want to recover from a failure, what you do? The state of the database before transaction execution is available through the shadow page table, and that state is recovered by what you do? You reinstated the shadow page table instead of the original table, and you continue the operation. This shadow paging is an alternative to log based recovery technique. The advantage is the overhead of log file maintenance removed, faster recovery, because you do not have to do any undo redo. Disadvantage is there is a data fragmentation problem and the associated garbage collection problem. Shadow pages are updated with current pages at every checkpoint. Every first modification after checkpoint requires creation of a new current page. So, checkpoint operation should be performed in a proper mode, so that you do not have too many shadow pages every time. So, system crashes only lose the data that is on the volatile data, that is so what we say, okay, store it onto the disk. So, media failures entail failures like disk crashes also, and also you can have bad sectors. So, log based recovery techniques insufficient, cannot handle media failures. Similarly, media failures but however they are much more infrequent compared to system crashes. So, how do you protect against media failures? One is you have archiving, maintain a copy of the database separate from the database itself. So, this is a backup. These need to be performed online. It may be too costly to suspend the operations of a database only for backup purposes. So, this is a relative, it is not done too frequently, it is relatively infrequent activity compared to logging. There are two types of archival levels, one is full dump and one is incremental dump. Here in the full dump, which is called as level 0 dump, the entire database is archived into the backup, and in the incremental dump only the changes that have been done with the previous dump level is archived. This is a non-quiescent archival. So, checkpoint gets data from memory to disk, recovery from system failure using logs, Dump gets data from disk to archive, archive plus log allows recovery from media failures, and then database is being modified as and when the dump operation is running. So, this is how it is done. You have the archive, you have the disk and the main memory. So, check data gets data from memory to disk, recovery from system failure, and dump gets data from disk to archive, where you have archive plus log and allows this recovery from media failures. So, online archival, write a log record called begin dump, perform a checkpoint usually and flush the log, perform dump, full log, either technique. Once all data are transferred into archive including the checkpoint, enter end dump in the log. So, how do you recover using these archives? Restore database from the archive, find the most recent full dump and reconstruct the database if it is an incremental dump. So, modify the database using the surviving log available in the archive itself and using whatever logging method was used previously. If you look at the summary of the recovery mechanisms, you have transaction states and ACID. Types of failures, you have log based recovery, no undo, redo, undo, redo, undo, no redo, and then you had shadow paging, and here we use for media failures we used archiving and backup. Now, let us look at the two-phase commit protocol. Before we go to two-phase commit protocol, we will have to discuss what is called a general paradox. Here general means the general, army general. Two generals are on two separate mountains. They can communicate only via messengers, but messengers can get lost or captured by enemy. So, the goal is to coordinate their attack. So, two people are on two separate mountains, they want to attack. If they attack together, they win. If they attack at different times, they lose. So, that is the paradox. So, if you represent this with the diagram, you have suppose the first general sends a diagram is messenger is 11 a.m. okay, and the second person says okay 11 a.m. sounds good, and this person says 11 a.m. it is then, and if this acknowledgement is lost. So, even if previous all these messages get through, the general still cannot coordinate the action since the last message could be lost. This is a distributed database issue. So, how do you recover from this? Possible reasons for not receiving a response to the sent messages: the message was not delivered, the target site was down, or the response was sent, but it was not got lost. So, transaction in recovery in distributed databases, coordinator transactions and sub transactions are there, and you have coordinator and subordinates. So, commit protocol, either all sub transactions of a given transaction must commit or none should commit. This property must be guaranteed despite any combination of site and link failures. So, this is what is commit protocol. So, you have two types of commit protocol, one is called the two-phase commit and the other is called the three-phase commit. In the two-phase commit, the coordinator sends a prepare message to each subordinate. The subordinate responds yes or no. If the coordinator receives yes, all yes, then sends the message commit, else it will abort. So, here what we are doing is we are having someone called a coordinator. This coordinator sends a prepare message to all the subordinates. If the subordinates send the messages and all are yes, then commit occurs, otherwise it does not. So, each subordinate must acknowledge the commit or abort the message. Coordinator on receiving acknowledged message from all subordinates writes an end log record. So, there are two rounds of messages, one is called the voting round, this is for getting those messages, one is called the voting round and the other is called the termination round. So, in the three-phase commit protocol, the coordinator sends a prepare message to each subordinate, the subordinate responds yes or no. If the coordinator receives all yeses, then sends a message pre-commit, else it aborts. Now, each subordinate must acknowledge the commit or abort message. The coordinator on receiving the acknowledged message from maximum subordinates sends a commit message. Coordinator writes the end record in the log file for the transaction. So, there are three rounds of message here, you have voting, you have pre-commit and you have termination. In the previous we had voting and termination, here we have an additional pre-commit. So, here the problem is that cannot solve the general's paradox, solve a relatively but simpler problem. Problem is called atomic commit in a distribution transaction. This means two machines agree to do something or not do it atomically, either they do it fully or do not do it, but do not perform the action at the same time. So, example, you want to transfer 100 rupees from one bank to another. You need to guarantee that both banks agree on what happened, but the two events do not need to be perfectly synchronized. Key concept behind atomic commit protocols is you use logs on each machine to commit a distributed transaction. So, what do we do here? Atomic transactions that span multiple sites or systems, we are talking about distributed. So, same semantics as atomic transaction on single system, which is the ACID properties. Failure modes, crash or other failure of one site or system, and you can additional problems that you have is a network failure. So, the atomic commit basics are the objective is to preserve data consistency for distributed transaction in the presence of failures. Here we are talking more in terms of distributed transactions. So, what is the model you use for each distributed transaction T? You have one coordinator and a set of participants or subordinates, which we have already said. So, the coordinate knows the participants, but participants do not necessarily know each other. So, each process has access to a distributed transaction log. It is a new log which is called a DT log on stable storage. So, the setup is this: each participant has a vote. The vote is either yes or no, and the coordinator takes a decision, and the decision is commit or abort. So, the specifications are this: AC1, all processes that reach a decision reach the same one. A process cannot reverse its decision after it has reached a decision. The commit decision can only be reached if all processes vote yes. If there are no failures and all processes vote yes, then the decision will be commit. If all failures are repaired and there are no more failures, then all processes will eventually decide. So, these are some of the atomic commit specification. So, any participant participating in a distributed transaction along with the coordinator must say that whenever they reach a decision, they all reach the same decision. It cannot reverse. Once it does it cannot, and the commit can be done only if all agree to vote and yes, and if there are no failures and all processes write yes, then the decision will necessarily be commit. If all failures are repaired and there are no more failures, then all processes will eventually decide what to do. So, the two phase commit is this way. Phase 1, when coordinator is ready to commit the transaction, place prepare T state in log on stable storage and send vote request message to all the participants, and then you wait for replies. This is what the coordinator will do. The coordinator in the phase 2, if any participant replies abort T, you place abort T state in log on stable storage and send global abort T message to all participants, and then you locally abort the transaction T. So, now what this happens is one participant says abort, then in that case you will place that abort the transaction in the coordinator will place it in the stable storage, and then it has to inform all the other participants that this this transaction has been aborted, and then locally within its own system it has to abort. Even one participant says abort. If all the participants say ready to commit, then you will place commit T state in log on stable storage, then you send a global commit just like there to all participants, and you will proceed to commit the transaction locally. In the phase 1, when the participant gets a vote request, remember we had phase 1 and phase 2, we were talking about the coordinator here and two phases of coordinator, what the coordinator will do. Now, we are talking about the two phases where the participants what they will do. So, if they want to reply ready to commit, you place a commit T state in log on stable storage, send global commit message to all participants and proceed. Participant gets vote request from coordinator, place abort or ready T state in the local log, reply abort T or ready to commit T message to coordinator. If abort T, locally abort the transactions. Here he has to wait for global. So, once he sends it in the phase 2, then he has to wait for the global abort or global commit message from the coordinator, and he has to place abort T or commit T in the local log because of some other participant, and you also have to abort or commit locally per message. So, this is the two phase protocol. So, the coordinator sends a vote request to all participants, and on receiving the participant perform the actions, it will execute the transaction locally, will vote yes or vote no, and will send vote yes or vote no to the coordinator. In the phase 2, the coordinator commits or aborts the transaction, the coordinator decides to abort or to commit, and the participants on receiving that has to commit or abort to the log. So, this is a two phase commit. So, here the coordinator he prepares then vote request and then waits, and then if once it gets the reply, it will send it either an abort or a commit. Here from the participants angle, it will initiate, it will get ready, and then it will give the reply, and then it will get the global. So, there are in the two phase commit, the failure modes are from the coordinator's viewpoint, his own system can crash, or because he can permanently be in a wait state because some participant has not responded to the vote request, and from the participant's viewpoint own crash, or there is no message from the coordinator regarding the global abort or the global commit. So, participant crash, network failure, timeout is considered equivalent to abort. So, place abort T state on stable storage, send global abort and locally abort. So, In the case of coordinator, so that is when the participant crash. If the coordinator crashes, you have to inspect the log. If abort or commit state, resend corresponding image. If prepare state, either resend vote request or do this. So, the participant crash, so inspect local lag, it can be commit state, abort state, no records or ready state. And here so widely used in distributed transaction database systems, generally works well when coordinators are likely to reboot quickly and when network partition is likely to end quickly, but it still is subject to participant blocking out the coordinators requests. So, what if the coordinator crashes during phase 2 before sending, then all participants will be blocked forever. Partially solution, you have a cooperative. Remember, the participant does not know the participants. So, you have a cooperative termination protocol, that is participants on timing out can make progress by asking other participants if the identity is known. If any participants had heard abort, if any participant sent vote no abort, if all participants heard vote yes, but one has heard commit or abort, can we commit? The coordinator should have written the abort to its log, otherwise you cannot do that. So, these are the some of the limitations so of the 2-phase commit. Now, then we have what is called a 3-phase commit. In this 3-phase commit, what happens? The coordinator sends a prepare message to each subordinate, the subordinate responds yes or no. If coordinator receives all yes, then only it sends the pre-commit, else it aborts. So, each subordinate must acknowledge the commit or abort message. Coordinator on receiving the acknowledge from maximum number, remember here, then it sends a commit message. Coordinator writes the end record in the log file. So, there are 3 rounds of message as already discussed: voting, pre-commit and termination. So, these are the 3 rounds that they use. Now, here so we have seen 2-phase and a 3-phase. In the 2-phase, what happens? The coordinator sends a message and then for the decision. If it votes, then it says if it receives yes, then it does the commit, otherwise abort. Once it decides to do that, it sends a global abort or a global commit, that is all. Here we have one to see whether the in the 3-phase we have voting and also we have a pre-commit. So, one more round before the actual termination occurs. So, in this lecture we have talked about the different types of failures, outlined log based recovery. We have also explained the concept of shadow paging, and we have discussed the various types of media failures and also outlined the 2-phase commit protocol and little bit discussed about what is 3-phase. So, here major questions that I want you to do is discuss the various types of failures and draw a flow chart and explain the 2-phase commit protocol in detail. Thank you.